Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming to you from the Mozaic Works studios. And today I think it's time to talk a bit about AI, the LLM developments, the GPT bots, and what is the impact of these technologies on how we develop software. And in order to do that, I found a few articles that I like to go through, but first let's just talk a bit about the general ideas. First of all, AI is a domain that tends to develop in big jumps. There's been a big jump around the 50s, if I remember correctly, then around the 70s. When I was in university, neural networks were all the rage, and suddenly we had quick development in that side. And then in the past few years, I think particularly due to the fact that we have a lot more data available for training such systems, we saw a big growth in AI. It seems like once again there's a big jump in what these tools can do. But it's important to ground them into what they are. So the latest big jump is something called LLM, which is basically large language models. These types of models, as far as I understand, I'm not an expert, but what they are doing is they are recombining things existing in their training models in ways that are optimized for convincing. And because language in general can mean a lot of things. Language in general can mean, of course, text, and we can see conversations with ChatGPT, but language can mean also visual symbols, and that's why we can generate images with GPT-3. And of course, programming languages are also language, so we can in theory generate code using GPT-4. Now the question for all these things is how good is the output? And based on what I've seen in various articles and from various experts trying it out, GPT-4 and ChatGPT tends to have a few problems. First of all, when you are chatting with these types of bots, they can generate convincing texts, but that's not necessarily accurate because they don't have a logical connection always. It's just basically it's a statistical model, is something that they pick and combine words together in a way that sounds good and sounds convincing. So an interesting application that I've heard for ChatGPT was a history teacher who decided to generate essays in ChatGPT related to history and then ask the students to correct them, because their GPT-4 and ChatGPT actually can generate a lot of issues in the texts. So this is one side of things, and if you look at how this applies to code, what this means is that it will recombine pieces of code existing in its training model and create code that might work or might not work or might fail in strange ways. So it's worth noting that while ChatGPT can actually generate a lot of things, there needs to be an extra step. There needs to be an extra step at validating it. So then, right now what I'm thinking about this is that you could presumably use, take a big problem, split it into smaller problems, and for each small problem, use something like ChatGPT to generate parts of your code, and then correct that code. And the next question is, how do you correct that code? Well, if it's a large piece of code, it gets more difficult, so it will probably work on smaller pieces of code. And even then, it's not certain that you can actually find all the issues. So I think that probably the best way will be to write tests for this and make sure that it is tested. Now, if we look at this from another perspective, we can actually, let me show you quickly an article. It's called AutoGPT Agents Want to Automate ChatGPT and Overrun the Internet. It's an article published on the Newsstack by Joab Jackson, April 13th, 2023. And this article talks about an interesting point that you can build on top of GPT-4. So, and do something called AutoGPT. What it's saying now that the ChatGPT from OpenAI has caught the fancy of the masses, clever AI types have started pondering on how the chatting portion of generative AI service could be automated away and have the AI just do stuff on your behalf. The early prototypes are rough, if not potentially dangerous, yet they offer enough promise that some enthusiasts are breathlessly calling them a primitive form of artificial general intelligence. Welcome to the rapidly emerging world of AutoGPT. Now, before we go forward, I think that we are quite far away from artificial general intelligence. And if the pattern with AI will repeat itself, what I would expect is that this big jump will actually come to an end, like in a decade or so, once we implement on top of it. Maybe it will be faster this time, and maybe we'll have the next wave of innovation coming on top of this, but yeah, who knows. But we are far away from having artificial general intelligence, and I think in general the hype with AutoGPT, with GPT-4, things like replacing lawyers and replacing doctors and things like this, that is not a good idea, and I don't think it will happen as enthusiasts imagine. So we are trying to be very grounded here in what is possible now and what might be possible in like 6 months, maybe a year. Okay, so what is AutoGPT? AutoGPTs are designed to automate GPT-4 tasks, enabling the creation of agents that complete tasks for you without any intervention. Why is this interesting? It's interesting because of the implementations. So a first example of an implementation is an AI-powered task management system. With a predefined objective, it creates and then executes tasks with the result of each task determining the following one. The script runs an infinite loop with the following steps. pulls the first task from the task list, sends the task to the execution agent, which uses OpenAI's API to complete the task based on the context, enriches the result and stores it in Pinecone, creates new tasks, and reprioritizes the task list based on the objective and the result of the previous task. So this would be a simple example of what can be done. And then what is also interesting is someone created an AutoGPT for sales prospecting, in which the agent can determine the top 50 companies, identify human resource director of these companies, send them emails. For those who responded, book meetings on Calendly, all on behalf of the sales agent. So it's a bunch of steps that may build on top of each other in terms of calling OpenAI's GPT, or the result of one of them will inform the next one, and then use OpenAI to keep on to continue until you you do what you achieve your goal. And the most interesting one that I found is, for coders, there is a test-driven development agent that creates software features, but just by iterating from a set of tests provided by the developer. So let's see this. And this is a Twitter thread by Adam CH, Adam Cohen-Hillel. Adam Cohen-Hillel. And he worked with his brother to create a coding agent that follows the TDD methodology. So basically, first write the tests, and then the agent runs in a loop until it creates the feature properly. Now, the next step, if you think about this, one of the next steps could be, how about if you manage to explain the feature in a way that allows it to generate the tests first, and then from those tests to move on and generate the code. And this is very interesting. Of course, he's saying it's a bit rough, doesn't work all the time, obviously. I mean, but it's scratching what is possible. And I think one thing that TDD practitioners know is that TDD is much easier to keep up, to do on a long term than any other way of developing software. And the reason for this is because it takes a big problem and it moves a lot of the decisions that you need to make. So usually when you develop software, you need to make a bunch of decisions. With TDD, those decisions tend to be kind of linearly as a number. They tend to be kind of constant during the development process. Whenever you are developing in other ways, you tend to make more decisions upfront or more decisions later on, or you make a mistake and then you spend a lot of time trying to figure out the mistake by doing debugging and other things like that. And TDD actually moves a lot of the things that you need to think about into a mechanical process, and kind of splits the types of decisions based on what step you are in the process. And because of this, I think that TDD is quite possible to be automated in a way. And the big problem still remains, how do we define the feature in a very precise way? Which is still coding, by the way. So we may end up with a different type of development in which we look at the feature, analyze it, extract the tests, and then based on those tests, we generate the code. And the interesting thing about this way of working, it opens up a lot of possibilities. So imagine you have a bunch of modules that are developed in this way and that communicate through some interface. If one of them isn't functioning properly, you can always regenerate it. Or if you realize that you missed a test, you can add another test and do a regeneration. So the speed of change becomes even better. Change speeds up a lot with this type of way. And I actually thought about this a long time ago. And I thought about what if we had a kind of universal machine that would get tests and you get features out, functioning features. And with this in mind, let's look at an article by Michael Feathers. It's called Possible AI Impacts on Development Practice. Michael Feathers is very well known for his contribution to legacy code and to technical debt. But in fact, he is a very deep thinker. He thinks a lot about various aspects of software development, and this is why it's very interesting to see this article. Now, what he is talking about in this article is that we can't accurately predict AI's impact, but we can explore some possible disruption points. And there are two main disruption points. One is source code and the other one is modularity. And for source code, basically what's interesting is that you have software systems. Most software systems are developing using source code because source code aids system understanding and enables fine-grained parametric control of behavior. Basically, it allows us to understand the system, it allows us to modify it, and this parametric control, it allows us to parameterize parts of code already written for other goals. If you change a parameter, if you add a parameter, and so on. Source code is a very flexible material that we use. And it's also one that's very close to language. But then when you introduce things like ML or database systems, these are systems that don't necessarily have everything transparent inside, and the way he's stating it is we sacrifice the rapid fine-grained control of behavior the source codes provide in order to do things not easily achievable otherwise. Source code is a compact way of parameterizing behavior, but we don't necessarily have to use it. So programming languages, this is another thing. This is more like an analogy that he is doing. Programming languages are built on top of each other. So for example, Java, when it was created, it was built on top of C++, and then at some point it was written in Java. But initially it was written on something else. So, and C++ was originally implemented as a preprocessor for C. And this is similar to how we would think about using GPT-based systems today, and are used to produce source code as an intermediate representation. We review the representation, we feed that into the build process. And is it necessary to do it like this? And what he's saying is the near-term answer is maybe. The output of GPT-based systems is probability-based, alterable by a temperature that produces novelty in solution generation, but also the change that the solution may miss, be wrong, or have bad consequences, the hallucination problem. So let me talk a bit about the hallucination problem, because it's something that's fairly interesting for a GPT-based systems and for large language models. Sometimes in order for the agent to produce a convincing answer, it will create references that don't exist. So for example, there's an interesting story that I read, a journalist who asked about himself the ChatGPT, and the answer included a lot of the things that were right, but also a few articles that sounded legit and included URLs, but that were not actually real. ChatGPT had created them to optimize for this temperature, so novelty and solution generator. It has a specific parameter. It's optimized for producing content that is convincing. And because of this, currently you need human validation. Human validation is currently a key part of the process, and source code is a traceable medium. It's easy to look at source code, right? As development moves to a generate and test paradigm, quality assurance will have renewed importance. There is a strong possibility that prompting replaces source code to some extent, however, temperature is a problem. Prompts are no longer deterministic specifications of behavior. Basically, for the same prompt, you can get different answers. Regardless, we may see the development of prompting languages with the aim of specifying must-have behaviors and placing constraints on stochasticity. It is likely these will be developed ad hoc in GPT sessions and later standardized. So basically, GPT would work with code if we pick small contexts or if we filter the output somehow. And one way of filtering the output is by introducing this option for, these constraints, the logical constraints. One such constraint would be the tests for the system. Other types of constraints might be rules for specific domains and so on. Another thing that he's talking about, so the second possible disruption points, is modularity. As the sizes of AI context windows increase, the size of generating modules can increase. These modules can be read by AI, modified through prompts, and regenerated on command. Most systems that generate code have something I call the escape hatch problem. Invariably, there are things that cannot be easily done with the generator. Traditionally, the way to handle this has been to provide a way to drop down into a lower level representation and fill in the details. To the degree that this problem persists, generated modules can provide holes as escape hatches. Basically, what this would mean is that you would have AI generate a module, but then you could end up looking in parts of the code and modify them, more or less, right? Maybe everything is source code, or maybe only some things are source code, and it's optimized for different goals. AI enables a third way of composing software. A module with extensive functionality can be read by an AI and then rewritten with only the subset of functionality and any additional tailoring needed for a particular reuse. This is like an automated private fork. This is something I hadn't thought about before reading this article, but fundamentally this is how it could happen. First, the AI could write a set of tests that have 100% coverage of an existing module. Second, run mutation testing, so that to ensure that the tests are actually covering everything. And thirdly, pick only a few tests and based on those generate the code. This is something that might be possible based on what we've seen so far. And a very interesting scenario, right? Because we could take legacy code, split it into smaller modules, make it better fit, something like that. Another possible scenario for development is the use of peer AI systems that negotiate feature sets with each other in order to arrive at a system design. Very interesting idea. This sounds more like the adversarial system for AI. It would be fun to see them fighting over design. It is hard to know what this means for modularity, but is likely the Conway's law will hold in many cases, with the modularization mirroring the interactions of the peer systems responsible for producing the design. Yeah, it's very likely Conway's law will hold, so we'll end up with modules anyway. And in conclusion, source code seems to have value for the immediate future. We could arrive at a trained AI that through interaction and learning understand the domain and its constraints so well that they can generate large target systems on request. If that happens, it might make sense to simply persist context as a set of embeddings, bypassing the need for source code. Basically, replace parts of the code with some settings, rules that define a domain. That'd be interesting. The relatively small size of context windows that we have today seems like it would be the primary motivator for the continued use of modularity in software development, but all of the uses of modularity outlined by Baldwin and Clark remain. Modularity isn't just a software concept, it's a strategy used in nearly all systems of scale. This is how the way things appear to me now. It will be interesting to see how it all plays out in the near and long term. And I love that he ends the article with no AI were harmed in the writing of this article. So what can we say after we've seen this? Some very interesting ideas. It's likely that we'll start generating more and more parts of software development. I'm thinking about things like the API interface. You could probably generate the interface of a REST API with ChatGPT. Would it do a good job? Not sure. It has to be filtered and validated. So we'll probably introduce a new paradigm, which is generate and validate, or the other way around, define tests that a specification, maybe have the AI write those tests and then validate them, and then generate and then validate. But basically what we'll have to do is some constraints and some context for the AI in order for these things to work. So the question is, if now, is this something that is more effective than what we have or not? And when will it become more effective? And to be honest, I don't have an answer to this, so I'm very interested in hearing from you. Have you used GPT for generating code or for any other tasks in software development? What have you noticed? Do these things hold? How much filtering, how much debugging, how much validation is needed? These are all questions that I hope we can answer together, and we'll come back on this topic later on once we learn more about this. So leave us comments with any questions, any thoughts that you might have about the topic. Thank you kindly for the view, and until next time, remember to think, design, and work smart.